Hello, welcome to Super Easy Physics and Mathematics. I'm Orisheje Matthew. We are starting this episode. We're going to be handling the top 10 areas of two-dimensional shapes that you need to know. So we're going to be starting today. So let's look at the first one here. It's rectangle. And the rectangle, how do we calculate the area of a rectangle? Is the base times the height. So we're going to look at example. For example, if the base is 6 cm and then the height is 8 cm, so what is going to be the area? Area is going to be 6 cm multiplied by 8 cm. So the area is going to be 48 cm square. So this is how you get the area. All right, so the second shape we have there is a parallelogram. A parallelogram is a two-dimensional shape with two sides parallel. So we have this parallel to this, and then the horizontal lines are also parallel. So if we have this base, the area is the base times the distance between these parallel sides. So if we want to calculate this, assuming that the base is 10 cm and then the height is 5 cm. So what is the area of this? This will give us 10 cm multiply 5 cm. So the area is 50 cm square. So this is how to calculate the area of parallelogram. All right, so we're going to be looking at the area of this triangle. And then a triangle, you have the height and then you have the base. So let's look at example. For example, if this base is 10 cm and then the height is 4 cm. So what is going to be the area? The area is going to be half times 10 cm multiplied by 4 cm. So this will be, you can use, instead of using these two to divide 10, and I can easily multiply by 10. So I can use this to divide this to give me 2. So 2 times that will give me 20 cm square. There's another way we can calculate the area of a triangle. So when you have an angle between them, so let's put this one angle 30, and then we can close this point here. And then here is 5 cm, and then here is 6 cm. So we want to find the area of this triangle. So the area of this triangle, area is equal to half AB sine C. So how do we call this? So we have here, this is A, this is B, this is C. So the side facing A, so in this case, A is equal to 5 cm, B is equal to 6 cm, and then angle C, which is this point here, angle C is 30 degree. So what is the area? Area is equal to half times 5 cm times 6 cm times sine 30 degree. So this will become, this can cancel this to give us 3. So give us 15 sine 30 degree, which is equal to 15 times half. So half, that is equal to 7.5 cm square. So this is the two ways you can calculate the area of triangle. All right, so the fourth shape we are looking at is a trapezium. We have two sides that are parallel, and then you have the separation distance, which is the height. So let's look at, in this case, we can say this is 7 cm, and then this point here is 5 cm. and then the distance between them, let's make it 6 cm. So what is going to be the area? The first thing is find the sum of the parallel side. So we can do that. We have 5 plus 7. So we have 5 plus 7. Okay, I'll leave out the height. I'm being deliberate. So this will become half of 12 cm, then multiply by the height. So which is this? So it will confuse you. So times 6, then times 6. Okay, so if you look at this, this can go into this to give me 3. So that will be 36 cm square. So this is how you calculate the area of a trapezium. Okay, so the next one we're going to do is to find the area of a rhombus. And when you see a rhombus is q square. So all these sides are basically equal. So if you have this, we can have, let's say, okay, this is 10, and then this is, once we have the dimension like that, so we can say, let's D1 equals to 8 cm, then D2 equals to 10 cm. Okay, so we can calculate the area. So the area is half times 8 cm times 10 cm. Okay, so this go into this 4. So that will give us 40 cm square. So this is how you calculate the area of a rhombus. All right, so the next one shape that we have is the area of a kite. Now for a kite, these two top are equal, and then the two bottom line are equal. The difference between rhombus and kite is that two of the line are longer, and then the two of the top here triangle. So we will have two isosceles triangle that are coupled together. So we have an isosceles triangle with a longer length, and then you have another isosceles triangle with shorter length. So once they form a composite shape, then you have your kite. So how do you calculate the area? So we can calculate the area by multiplying the diagonal, the length of the diagonal, then you divide the product by 2. So let's look at this one, where the longer diagonal is 12 cm, and then the shorter diagonal, the horizontal one, is 8 cm. So what is the area of the kite? So let's insert our value. So you have half multiply by 8 cm multiply by 12 cm. So 2 go into this to give us 6. So that will give us 6 times 8. That will give us 48 cm square. So this is how you calculate the area of a kite. So let's go to the next shape. All right, so the seventh two-dimensional shape that we have is a cycle. So a cycle, the line that connects the middle of the cycle to the circumference is called the radius. So once you know the radius of the circle, you can calculate the area of the circle. And then the area of a circle is pi radius square. So let's take a circle with a radius of 7 cm. Okay, if the radius is 7 cm, then the diameter will be 14 cm. So radius plus radius will make up the diameter. So if you have this, so the whole of this to here is 14 cm. Okay, so it's just to explain that. So now, what is the area? Area is going to be 22 over 7 times 7 times 7. So 7 can handle 7. So we have 22 multiply 7 cm square. So that will give us 451 cm square. So this is how you calculate the area of a circle. So the next one I'm going to be looking at is we're going to be looking at the area of a sector. All right, so the 80th shape that we are treating in this video is the area of a sector. Now, what is a sector of a circle? A sector of a circle is a part of the circle that is bounded with two radii, OB, OA, and then the arc AB. So this shaded red portion is called a sector. So how do you calculate it? A sector is just a fraction of the cycle. So once we know the area of this cycle, we can get the area of the sector. So the area of a circle is pi radius square. So a sector is just a fraction of it. So all we need to know is to know the angle here. So if here is 60 degree, and then the radius is 7 cm, so we can calculate the area. So it's going to be 60 degree over 360 times 22 over 7 times 7 times 7, all in cm square. So this would become 1 over 6 times 154 cm square. So this cancel this. So this times this is 154. So if you divide this, okay, we can do this now. So you have 154 divided by 6. Anything that can divide the denominator, use it to divide the numerator. So I can do this, divide by 2, and then also divide by 2. So this will give me, so the bottom, the denominator is 3, then the top is going to be 7, so remainder 1, that is 77, all over 3. So 3 can go into 7, that will give me 2, remainder 1. Then 3 go into 17 will give me 5, remainder 2. So 3 go into, so that 2 adds 0, that will give me 20. So 3 going to 20 will give me 18, which is 6, 2, 2, 2, 2, 16, 16, 16. So it's going to be that dot. So which is equal to approximately 25.7 cm square. So this is the area of the sector. So the next shape we are going to be looking at is a section of a cycle, which is called the segment, which is the shaded portion. So what actually is if you have a sector, then you draw the chord. So this portion here, so y here is theta, here is r, which is the radius of the circle. So that is the segment. So for you to do that, it's going to be the area of the, so let's do this. So you have triangle plus segment to give you sector. So to get the area of sector, so what is the area? Area of segment is equal to area of sector, take away area of triangle. So this is how we do it. Now let's look at, so what's the formula? Area of sector is theta over 360 times pi radius square. Take away area of triangle, which is arrow square sine theta over 2. So we can use it. So let's assume this is 7 cm, this is 7 cm, and then here is angle 90. So what is the area of this segment? So we can substitute our value. So this one will become 90 over 360 times 22 over 7 times 7 times 7. Take away 7 times 7 sine 90. Sine 90 is 1 divided by 2. So this is going to give us 38.5 cm square. Take away 24.5 cm square. That will give us 14 cm square. So that is the area of this segment. So remaining one shape to go. All right, if you have followed me to this point, you are making progress. So we're going to be looking at the surface area of a sphere. So if you have this, what is the surface area? It's very easy. That is 4 arrow square. So that's actually the surface area of a sphere. Okay, so if this sphere have the radius of 3 cm, so what is the surface area? Surface area is going to be 4 times 3 square. So which is 4 times 9 cm square. So it's going to be 36 cm square. So that is the surface area of this sphere. So I want you to subscribe to Super Easy Physics and Mathematics. Thank you for going through this one. Comment on the video